Welcome to another edition of Talk Physics. Yeah, that's all. And nobody talks except me, unfortunately. So if you or someone you know is capable of talking about physics in some sort of reasonably intelligent way, just reasonably intelligent, um, email me or something. And you can get into this room. All you need is a working microphone, really, but camera would be better. But whatever. The extent of your participation is up to you. This window is remaining non-compliant. I guess I have to minimize it the hard way. Something like move to another workspace. No. Resize. No. Minimize. That'll do. All right. I guess I have the other window set to. That's interesting. Sorry, you don't need this part. And such. Put that in the background. All right, not much, no comments to really comment on, so we won't bother with that. Yeah, this is a little bit annoying. I have to fix that, I guess. Someday. Is this the one I want? Yeah, Lloyd's mirror. Ugh, gotta sort of move it over anyway. All right, so I've been doing a lot of looking at optical videos, lectures, and physics, and it's really, not too much to the rules, just the angle in, angle out, and then they call Snell's law, which is just has to do with how the light refracts going through a medium, whether the medium's lighter or heavier, and that'll change which way the light will be bent. Internal reflections and all that stuff is quite interesting. But the Snell's law is sort of based on this assumption that light somehow changes speed, which is the sort of the Huygens argument. And that was sort of Huygens's argument, is that light goes in and somehow it turns because one side's moving fast still, and the other side's going through the medium, so it's slowing down, and so the whole thing ends up turning. And it's an adequate metaphor or analogy, but I don't think it's a description of what's actually happening, because the individual photons are what's turning. So it's like they always draw it. It's a big pile of photons, and then draw what it's doing. But it doesn't function as a big pile. It functions as each individual photon has to do this thing. And each individual photon isn't moving faster on one side than it is on the other. I mean, that's the very idea that photons actually slow down is, I don't think, very good physics. They say it. A lot of, 50% of the physicists say they slow down, 50% say no, in a sense. That's my impression. They only slow down in our perception of them, in the sense that they're still going the same speed through the material, but the material is requiring them to go through processes of interacting with electrons, and as they interact with electrons, it takes time to get where they're going. The electron slows them down. It's like it's like you running somewhere and you have to push, big balls or something. As you're running, you have to push it 5 feet and then run, and then push a ball 5 feet. It just slow you down. And the same thing is happening to the photon as it travels through a medium. So it has to stop, and not stop, but it has to get involved in a system, get absorbed and readmitted in a sense, or it has to create pressure, and then the pressure has to be released, however you want to view it. The extent of what absorption means is a tricky concept, because absorption can sort of just mean it reflects twice or something, It's all been edifying and all that crap. And this Lloyd's mirror thing had come up a few years ago as another example, another way of doing the two slit experiment, even though there's only one source, one slit in the experiment as you actually do it. And it sort of doesn't make any sense because it's another one of these virtual things where the interference is with a virtual path that a photon takes. And it sort of breaks again, you're stuck saying, like with the interferometer, where exactly are these photons interfering with each other in any kind of wave way? I mean, clearly there's something happening, but is it interference? All right, I've argued pretty aggressively that none of these things they call interference are interference. They're just different. Each one has a different cause for the effect. The effects are similar, and they have a similar fundamental reasoning behind why they're happening, but they're happening in different mechanical ways. And you can't just keep blaming the pattern on the same kind of interference because it's just not there. Like, for example, in the radio wave experiments, they're fundamentally different because you never create the wave function, because you never have the antennas, or never the energy from the antennas, the photons, never interact with a material surface, so they can never be turned into wave functions. And therefore, where do photons begin and where do wave functions? And the same thing happens in this Lloyd thing, is because half of your energy, it doesn't have a wave function. They're obviously photons that are reflecting off the mirror, not wave functions. And if they were wave functions, your pattern wouldn't be the pattern they're arguing for. So it's not a coincidence that, whenever they draw this stuff, they're always drawing lines. It looks like rays of light. It doesn't look like waves. It looks like rays. And, maybe that would be maybe they should be saying wave-ray duality instead of particle duality. But it's, as this guy says in the comments again, so there's another concept where just, there's just a photon bounces and affects another photon. Well, that's not the argument. You can't, what other photon is there when you're sending in single photons at a time? I mean, the two-slit pattern is the same when I send just single photons through. So how can you make the argument that it's interacting with another photon? The whole principle of quantum mechanics is based on that premise, that these experiments can all be done with single photons at a time, which, gets hard to imagine with some of them. They haven't done it, but that's the argument. Let's see, and people just insist it has to be waves. I don't see where a photon bounces off or affects another photon, so I don't see where you have any evidence of any force ever bouncing off of a force. And I've argued that the whole gravity bending photons argument is nonsense. So I saw that today with a physics teacher, college physics, talking about relativity and, talking about optics. And he, brought this up. Okay, photons don't have any mass. Well, clearly for the purpose of making them capable of being affected by gravity, they have to have a mass. So you're giving them some mass. I mean, it might be infinitesimally small, but it has to be non-zero, or the equation says there's no effect. So you have to give them mass. It's just, you can't get around it for the purpose of doing the math. Let's see. Well, I agree in the case of one photon, it's probably a different phenomenon. Yes, well, they interact with electrons. That's what we know photons interact with. That's their specialty. So anytime you see a photon change, it probably changed because it hit an electron or electrons in a circumstance. So it doesn't really bounce off of anything but electrons. And the word bounce is kind of tricky because it doesn't really bounce. It's absorbed by the electron, and the electron usually is readmitting the energy. That's usually what's happening. So if it can't change the circumstance the electron is in. So the idea is that electrons and atoms are in specific locations, specific distances from each other, and specific distance from the nucleus, the protons. So they're held in tension. They want to go towards the protons, but to go towards the protons means they have to go towards each other. See, so if you have 3 photons here, I mean 3 electrons, one here, where this pen is, you can sort of understand that this one here in the middle can't go down. So if it was a proton here and it wanted to go to it, it can't get there without pushing on these other electrons that it's repelling against. So if it tries to go down, these two go out. And if the whole system is pressurized, you can see how that's not going to work. It's not going to be permitted. So what's happening is the electron isn't reflecting the photon. What it's doing is it's absorbing the energy and then readmitting energy. So energy pressurizes the other electrons, and all of them collectively say, I don't want to be in this position, and it moves back to its normal. When it moves back to the normal, the photon's emitted. Something like that, you could argue. But it's probably not something as obvious as there's an electron here, a photon here, the photon bounces off the electron, that's it. That's the end of the story. Probably doesn't happen that way too often. Might, for direct reflections, but it probably isn't the most common case. And clearly in rainbows, you have a water droplet, and you have light come in, it reflects off 2 of the surfaces in the water droplet, and you're saying, well, what's the surface of the water droplet? Well, the surface is made of something, and the photon is hitting something. So there's something causing it to change its direction. And I've sort of gone into possible reasons for that. So anyway, so Tricky Dick says for other reasons. It's not very informative. The photon bounces back and forth, trapped by the electron. Right. Yes, the photon is the force. That is the repulsive force between electrons. That's what photons essentially are. And that's sort of interesting. Oh, Bass Angular. What's up? I don't know. You want to have a what's up conversation? I'm supposed to... What is that? What's up? What are you expecting from me? I mean, it's just like people saying hello. It's just, it's just a distraction, right? I mean, I'm in the middle of saying stuff, and I'm supposed to say, oh yeah, hi. Don't get it. A lot of things I don't get. Anyway, so where was I? There were a couple other points I wanted to make. So, in all these discussions of wave versus particle, so they go through this whole spiel. So this professor uses the argument that, well, I'll re-paraphrase his argument. I guess so something like, well, you have both nipples and a penis. I don't call you just nipples, and I don't call you just penis. A girly boy or manly man. Like his example is you have a job and you're a student, right, or some kind of crap like that. That you can have these dual roles and blah blah blah, and it's just mush, that this duality, and his bias is so obvious in terms of how he strongly thinks photons are more wave than they are particle, but he has to concede that in some cases his wave theory just doesn't do it. It's not going to explain what's happening. And again, I'd say the wave theory just doesn't make any sense when it comes to describing a photon interacting with a surface that it's going to get deflected by, because the photon is too small to even imagine how any surface could create a speed change on one side versus the other side, where somehow one side of the photon is moving faster than the other side of the photon. Just kind of doesn't work as a mechanical explanation. So, how's your day going, Gary? I mean, people are just so, it says LOL anyway. People are funny. Ha 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 ha. Thank you. Max said he's coming out to see you. Smart ass. Yes, that's what he's doing. Or it's none of your business, I don't think. Anyway, whoever you are. Where was I? Yeah. So anyway, so you see a ton of these people just play with language and, pretending they can make this wave particle thing make any sense when it really can't make any sense. And anyway, when they ever describe particle, they do it in some way that it's never anything like what I've described. They never describe it in the sense that there's two components to the particle that would be called a photon. That you can't really have a photon till you have more than one, because the frequency and the wavelength is dictated by the space between the particles. They're always describing the particles as if they're some kind of variable length blob. That like a radio wave or something, a 20,000 hertz radio wave would be 15 miles long. And it isn't. I mean, there's no, the argument wouldn't be the particle is 15 miles long. So I just don't know how they seem to always avoid thinking of particles like bullets or like bowling balls or like cannonballs. They never use those analogies for a particle. And clearly it doesn't fit with the photon argument, because they use the word photon to describe something that definitely has a frequency. That's how we can detect the different photons. But we're only detecting them because there is more than one quanta of energy. So you could have something like Planck's constant, and that establishes how much energy there is in a single photon. And it's some whatever 10 to the minus 15 kind of number or whatever it is. And obviously you'd have to kind of double that, because the real constant is for the single bit of a hunk of light. And this is the real problem, is that they really can't, these things are of such tiny amounts of energy. We can't measure them as individuals. We can only measure them as a group, and then make a statement about how much there is. How many there are just depends on, again, how we establish what the constant is. And so I'd argue that constant is twice as large as it should be. And that when you use the real constant, then you have the constant for gravity also. Mathematically, you have the amount of energy that there is in the smallest quantity of gravity. The smallest influential bit of gravity would be half the smallest individual bit of electromagnetic energy, because the electromagnetic energy is, by definition, has to be at minimum two things. So you can measure the distance between them. It has to be two cannonballs, or there's no frequency. It has to be two bullets, so there can't be a frequency. There has to be two. But I've never seen any of them describe a particle that way, which seems just kind of strange, right? That they wouldn't ever describe the particles as bowling balls or cannonballs or baseballs or bullets. Never. Because they have to use this frequency term. All right. So, now, so the other thing with frequency and wavelength, I've sort of complained about this, that this seems like such a math gimmick to have lambda and then frequency, and in equations when the two concepts are exactly inverse to each other, you really can't separate them, and they try to. So you really see this when in optics when they're talking about refraction and the slowing down of the light, because what they say is the light's wavelength doesn't. Let's see, the wavelength is the one calculated in the one in nanometers is the one they think is slowing down. So the light's wavelength is getting shorter, but its frequency stays the same. Doesn't make any sense, but that's the only way they can make it go slower, because the two frequency and wavelength are inverse. That is, wavelength goes up as frequency goes down, and vice versa. That apparently the gimmick is then when you multiply the two times each other, so when you multiply the quantity in nanometers, how close they are together, times the time component of how many hertz, you end up with the speed of light as a number. So hertz times nanometers, and because they're inverse, that is, if you go smaller nanometers, you go higher hertz. It always ends up being the speed of light. So that was something I didn't know about another reason how that's sort of an engineered. It's almost giving wavelength and frequency a sort of constant status, because in a sense you've pre-limited their function. So anyway, that's sort of interesting, but it does explain why the math has these kind of what I call gimmicks in it, where you're using both wavelength and frequency in the same equation, and then even multiplying them times each other, which, is, I mean, if your weight was proportional to your length, that is, if for every 10 pounds you got exactly 2 inches taller, and every 2 pounds you got 2 inches taller, you could sort of understand how it's sort of a gimmick, to have one number going down, when you're measuring the other number based on how much less tall you are, or it's probably the wrong way to say it, but it's just they're clearly tied together and they can't be untied as concepts. So just doesn't. It's hard to make that mean anything. So anyway, it's sort of interesting, and I'm still, do the Twans smell like farts? So Bill is the cowboy apparently. So he's such a grown-up. He can say fart. Everybody's really impressed. Ooh, he said fart. Hey. Amazing. So anyway, you just wonder, I said, well, why? Why aren't these people, properly managed? People who do this kind of thing on the internet. Seems they need some management. Like waste management. like we do put garbage out and we put it in a dump, and certain things we try to do. It seems like the kind of people, that need to be waste managed. So anyway, this Lloyd's thing is interesting. I figured I can duplicate some of this quite easily, and I just thought I'd mess around with it. But I mean, it's kind of funny because it reads as if this was somehow validation of wave theory, when clearly the whole thing is illusion theory. I mean, there's half the path isn't a real path. The light doesn't actually travel. So it's like you can't make any sense of it, how it could be being affected in a virtual location, where it doesn't actually exist and never went. But yet somehow it got dirty there, like something happened to it in the virtual space. That can't happen. So it doesn't make much sense. All right, so what else do I want to cover? So yeah, I've just been doing a lot of absorbing of information, and for future utility. It's just there's so many little things to collect as information. So gigahertz, is the range for like microwaves and radar, and terahertz is the range of light. So I never really knew where exactly it existed, but it's in the hundreds of terahertz. So you have to think of it in that terms, like 1 gigahertz is 1,000, 1 terahertz is 1,000 times bigger, but you got to think if you have 400 terahertz, that's 400,000 times bigger, which is a lot faster, a lot smaller wavelength. So it just gives you some perspective on how far up the scale light is, how rapid the frequency is. Anyway, but it's all that little stuff, remembering all these little, useful bits of information that I'm not very good at writing down, and I really should, because it's the way to help your memory. So is there anything else that really, like I said, there just isn't much. I just figured I'd make a video, say hello, and just say a little bit about this idea that I think if they didn't force this wave particle duality and just did more of a conversation about the form that the energy is traveling in, then they might be able to concede that ray might be a better way to say it than wave, because essentially rays do the same things their waves do. They have you could argue that a ray has a center, and so much of what happens with waves always collapses to the center. So it's like even the Feynman kind of argument. Feynman's arguments about probability are really just about canceling. It's really about there's this straight line, and there's crooked lines going this way and crooked lines going this way. And if all of these are irrational, they just cancel out, and you're left with the one in the middle. And the probability isn't 99.9999. No, the probability is 99.9 forever. It's a huge improbability of anything else happening because they all canceled out. So I mean, but it's all these ways of looking at things. It's just, so anyway, I'm just trying to come up with the point to be made is that there's no evidence demonstrating that the cannonball theory can't explain. They just don't like it. Okay. But they haven't excluded it with any real evidence, except their own inability to describe it in some sort of more rational way. So Like, for example, Feynman talking about Newton's glass and kind of just talking as if, well, if this spot theory doesn't work and this football theory doesn't work, then therefore all the particle theories have been disposed of. When you could argue there's could be dozens or hundreds of alternative explanations that could explain the phenomenon, and you're just pretending you somehow eliminated them all when you didn't come close to doing that. So anyway, so there's nothing fundamentally incompatible. There's no experiment that just says this is it. It can't be. There's no particle explanation that explains this experiment. And sort of likewise, there's no glaring explanation that says there's no possible way to make this into a wave thing. Now, I'd argue this Lloyd thing is, you have to really strangle the experiment to explain how wave functions, single photon wave functions, are going to manage this, where the photon splits in two. Because see, what it's doing essentially is it's taking a single slit and creating a reflection of the single slit. So there's two slits now. But the problem is, single slits only work for interference if you have two waves coming out of them. You have two waves coming out of them and you reflect that. That's not the double slit then, because the double slit is only two waves. So this is the problem with their mechanics. As I've argued, using Huygens, there's just there's a gross inconsistency in the application, because in the single slit they create two waves, and then somehow in the double slit they only create two waves. And logically you're saying 2 times 2 should be 4, and somehow they don't come up with that. All right, so that's probably enough of that. So there hasn't been anything in the descriptions. National Science Guide, nothing. So yeah, there hasn't been anything interesting happening. So maybe I'll just play some of a Ken Wheeler magnetism video, which I haven't watched yet. It was only like part 4 or something. And yeah, I just never got around to it because it's, it's tedious and there's no answers, and I just still haven't played it. I've had it loaded in my browser for 2 months, and I just couldn't get interested because I know it's going to be horse shit.
Let's go on to section 4 of my lecture on defining a magnet. Something basically everybody in the world thinks already been defined, but that would be incorrect in the extreme.
Well, I think everybody in the world knows it hasn't already been defined, because then they would already know what the answer is. They'd know where the energy is coming from, and they'd be able to tell you, and they'd be able, we'd all be able to just say why magnets attract and why magnets repel, and we'd have an obvious answer. Well, because the little cannonballs are doing, or whatever the answer would be. But we'd have an answer. But your answer is no answer. It doesn't say anything. So that was another interesting thing, though, because yes, I'm doing all this optics stuff, and it gets into all the the really interesting thing is when you put the two pieces of glass on top of each other. So this is an experiment I'm going to play with quite a bit, with a layer of dust in between them. I mean, that appeals to me, right? Dirt is easy for me. And you get this really solid, and it's a completely on-off pattern. Okay, I mean it's real on-off. I mean it's like that kind of on-off. And you'll get that on like a round piece of glass or whatever. It doesn't matter. So you have essentially one hunk of glass on top of another hunk of glass. That's the experiment. I showed it in videos before. And what happens is the layer of dust between them creates, how it's described is it creates an unevenness. Okay, so the two things don't sit on top of each other flat. But I don't think that's the right answer at all. And then internal reflections and all of this other stuff going on. But it's just so clearly a bar pattern. I mean, it has no, it doesn't have any of its sinusoidal, it isn't doing this gradually on thing, gradually off, any of that crap. They're really hard bars. Light and dark. Clearly, lights goes to one place, no light, no light. And again, it has to do with and they're wide. It's not just some tiny location. So it's a whole place where nothing happens, but something's happening, because this, again, see, it's another one of these ideas. This whole interference thing is based on some kind of concept like light plus light equals dark. And that it doesn't make any sense, doesn't conserve energy. You can't wipe out 2 photons. Light plus light equals dark. And you kind of know, you surmise, that in the photon experiment, what's really happening is the photons aren't going to one spot and they're doubling up on the other spot. There's twice as many as there should be. So they're really just moving from landing here to landing here or landing over here. They're just not going to land here, And as I've argued in radio wave experiment, that's going to be a clear example, because there is no doubling up, because it's not anything like true interference, and the signal is still there. You've just made a dead spot because you've jammed the 2 signals. So the same energy is going to that location. There's the same amount of photon energy is hitting the spot. You just can't receive it because the 2 signals are overlapped, out of phase, which means their frequency has been substantially doubled, substantially changed. And you're not going to receive it at its old frequency. You have to receive it at the new frequency, that energy. So anyway, the Stephen Burrow guy is still been working on the microwave experiment, and it's been fairly a learning curve and all this stuff. And the equipment gets very sensitive when it comes to the shape of the wave. How consistent the burst of energy is produced is very important to some of the more sensitive equipment. And the rawer equipment isn't too good at, we'll see how bad it is. It's not very precise, I guess is the point. So, but I think eventually we should be able to find a way to do this, to demonstrate jamming. It's hard to, the point is it's hard to demonstrate in using small enough, a high enough frequency to be able to do the experiment in a short enough distance. So to be able to keep the experiment reasonably sized, you have to use a high frequency, and the high frequency means the equipment starts to get a little buggy in terms of detecting. So anyway, that's just a side subject. So anyway, the point I wanted to get to about this was it got me thinking about the ferrocell. So the famous Ken Wheeler, let's watch light get bent by magnetism nonsense. So this pattern, it has an awful lot of similarities to, the typical ferrocell patterns, or, like light is being converged, and, it's supposed to be representing the magnetic field and blah, 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 blah. And a key to it is that the light that makes these lines visible I haven't, like I said, don't have a ferrocell, but I have ferrofluid, and I plan on making some sort of devices, and hopefully ones I can put under a a microscope. But the ferrocell is basically creating these lines, and I would kind of argue that they're the same lines that are being created here. They're just being distorted because of the way the particles are being lined up. So if technically I did this experiment with just ferrous oxide, maybe no fluid even, I'll get this pattern. The pattern of I'll get more shape to these lines because it will be uneven. The surface of the glass, the pressure will be uneven, and the unevenness in the fluid, the small film, the oil layer. See, in the case of this, it's just an air layer. I wish this light was, well, I have all these effects on. That's the real problem. Showing the images backwards. This is just done with air. And when you use a fluid, then you change the reflective index because you're going to a heavier material. So you're going, and so you change what's out of phase. So that's what's going to change the output. And the fact that the dust can be moved by magnetism, essentially. So if you could move the dust that's in between these two layers, it would be interesting to see how much you affect that pattern. I mean, I bet you would affect it dramatically in terms of giving it shape. So anyway, that's I think that's part of the explanation of the ferrocell. Yeah, part of it. A big part of it. A monstrously huge part of it.
Nobody has an idea what the hell's going on. I love it when people tell me, well, Tesla or Schauberger or so-and-so figured this out. It's like, go find me where they say that.
Yes, and also go find me where you say it. You go find me where you say anything explaining why magnets move into each other or why they move apart, besides some vague notion that the hyperboloid did it, which is the same thing as saying the boogeyman or magic fairies. Oh, cool. It's nice that I can disturb you. I think the colors are sort of interesting myself. So, I mean, all I can suggest is you maybe put a little piece of paper over that portion of the screen or something. But yeah, I sort of like I like it. So I'm going to do it for a while. So sorry, you'll have to live with it.
And of course, no,
or choose not to.
But he ever does. So here we actually see looking at one quote-unquote pole of a magnet, and importantly, this is
so quote-unquote pole of a magnet. Like there's some dispute that magnets have completely different polar identities. Like there's something wrong with calling them poles. Like they aren't obviously different enough to be called poles in terms of their effect. I mean, clearly, it's just so obvious. You just turn the magnet, and you get a completely different effect. I mean, attract this way, turn it this way, repel. I mean, if there isn't something you could say was a perfect description of polar effects, that's it. So, I mean, it's just poles, quote unquote. I mean, come on.
Not only visible underneath the supercell, it is absolutely testable with any Gauss meter. You actually have a high pressure zone in the center.
Let's understand that a Gauss meter is just another way of testing with another magnet. You're just using another compass needle to tell you the strength of the magnetic field. So there's no other way to do it. The only way to detect the magnetism is to put a magnet in the field created by the magnet, in the proximity of the magnet. So the simple argument I'm making is gravity goes in both directions, all directions, and it comes out of a magnet magnetized in the sense that the gravity was red and black, let's say, the little force bits, all mixed. And when it comes out, the stuff that goes in this side gets segregated. So all the red stuff comes out here and all the black stuff comes out here. And the stuff that went through this way comes out, all the red stuff up here, all the black down here. So the gravity gets filtered by the magnet and creates a field around the magnet that's now producing stuff going out. So the stuff going in is mixed. The stuff going out, the stuff it's radiating, because it's not holding it, it's not absorbing gravity. Nobody absorbs gravity, so to speak, until you actually move in the gravity. But once you're in a stable gravitational position, the same amount goes in as goes out, blah, 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 whatever. It doesn't matter. The point is the gravity goes through the object more than it's absorbed by the object. And when it goes through, it is being fundamentally changed. That is, little red bits to go in this end, little black bits pop out. No, this is the red end up here. So little red bits that come in this bottom fly out this top, and little black bits that come in this end come out the bottom. It's filtering it. And so when it does that, all the out, so it's like a light bulb. If you thought of a light bulb as being something that wasn't fed by electricity, but if it was, you thought of it as being fed by radiation, like X-rays, like radiation you couldn't see. So radiation you couldn't see goes into the light bulb, and then the light bulb returns it as white light. So it goes in one form and it comes out as another form. And that's what a magnet's doing. So the field around the magnet, this radiating field that's working exactly like a light bulb, in the sense that it's the inverse square law, it diminishes because it's rays of force. You know, in spite of calling them Maxwell's wave equations, they're clearly Maxwell's ray equations. And so then the only way to detect that change is you have to have something that's going to be sensitive to be able to tell the difference between when it's getting hit by black stuff or when it's being hit by red stuff. So you either have to put an electron and a proton on a string and do it with those, or you have to do it with a magnet. That is, an atom that's lopsided, that'll tell you. An atom that's ionized will tell you. That has an imbalance. That is, it's more black on one side, more red on the other side. Or a regular magnet, another little tiny magnet. And another little tiny magnet will orient itself exactly the opposite as this magnet, because the red bits will be flying out of here, and they're repulsive to red. So the reds will push away. You know, they don't want that. And but the blacks, if it was black to black, red to black, then the red energy goes out and the black energy goes out the other one. So you end up with no force. And so this end has attraction essentially to this top end, and it has repulsion from this end. So it basically turns and flips. It just says turn and flip. It's obvious. Anyway, simple explanation explains why there's attraction and repulsion, unlike Ken. Explains where the energy comes from. The energy is gravity. And I would explain that gravity comes from the universe. Like the cosmic background radiation, it's out there. Yeah, and it's coming right for you every day. All right, I thought gravity and magnetism isn't the same thing. Well, if you call the same thing, I don't know how to say it any other way. I mean, I've always said the whole point of the unification theory is the point that they're unified because they're the same thing. They're all moving the speed of light. So light, gravity, magnetism, all the same thing, just in different forms. At a frequency, it's the electromagnetic spectrum. Segregated, it's magnetism. And mixed and not at a frequency, it's gravity. They are the same thing. It's just one is filtered and one isn't. like Jack Daniels versus moonshine. Not a really good example at all. Tricky Dick. But yes, of course, you had to have a dicky answer. Something drunk and stupid in your analogy, indicating your origins and, whatever, Arkansas or something, Tena, Arkansas, southern Arkansas.
Intermediate pressure, and then we actually have a high pressure along the edge of the magnet. It doesn't matter what shape it is, cylinder, block, makes no difference.
So he is correct that this is about pressure, but how do you create pressure? That's the question. And I don't know how to do it. There's no way to get around the charge phenomenon. It's the way it, the repulsion between electrons is really, I've done this so many times, but it's like ping pong paddles with a ping pong ball bouncing between them. As you move the paddles together, there's more impacts, and the impacts are always at the same speed because the ping pong ball is moving the speed of light. So it's always the same force. So the more impacts, the more force. So you're essentially creating energy by creating pressure. But the only way to create pressure is to use energy. So you didn't create any energy, you just convert energy. So to make pressure, you have to create pressure.
What a Gauss meter can't tell you, however, is the nature of that flux.
Okay, of that flux. So that's some way of saying this stuff. The fieldy stuff, but we won't know what that is and how it pressurizes the magnets and how it creates the inverted pressure, the absence of pressure. That we're not going to get that explanation. One time when I was walking down the street of Soho in the rain, I saw a werewolf. He had a Chinese menu in his hand and was looking for a restaurant by the name of Lin Ho Folks. Okay, so we will say goodbye. We'll time out you or something, and then we'll say goodbye. Let's see, waves. That is the question. I don't. It's really not particles or waves as stated, in my opinion, but. I mean, again, you're stuck with this idea that so many experiments demonstrate that there is no wave in any notion of wave because your wave has it's not spreading at all. So, I mean, the word wave doesn't mean anything if you're going to create this new kind of wave that just moves in a dead little straight narrow circle. If you're going to create the word wave and it looks just like a bullet, I mean, if you're going to make the word wave applicable to bullet, then, there's no duality because you're just using, a silly description of the word wave. So that's part of this problem. We need another word for what you're really saying, which is this thing is somehow a disturbance in two different fields, which is even, in my opinion, I mean, it's bad enough to say something's a wave, but to say it's a wave in two different oceans at the same time, then you're really stretching it. And in my opinion, you're making particle more and more of a rational word.
I mean, it'd be like a meter not being able to tell you the difference between water coming out of your shower head or the water flowing down your drain. One is wholly different than the other. One is centrifugal and force, the water hitting your face, for example.
Centrifugal and force. So one's hitting you and one's leaving you. Is that the drain part? I mean, that doesn't even fit, right? I mean, there's just two little, one hits you and one doesn't. I don't know. It doesn't really make any sense, right?
analogously, and the water that's going down.
So again, does the frequency mean there's a wave? Well, like I said, I can give you 4 million examples of things you would never call a wave that come at a frequency. So I can throw baseballs at a frequency, I can hit tennis balls at a frequency, I can throw bowling balls at a frequency, I can lob ballistic missiles at a frequency, I can roll, I already did bowling balls, right, at a frequency. Shoot the bullets is the best example. I mean, obviously I can, you know, shoot bullets at a frequency, a rate. Frequency, and again, you wouldn't sit there and say the bullets are waving at me. You know, just wouldn't.
On the drain, of course, your drain doesn't have suction on it, but imagine if it did, that it is leaving, it is increasing.
It does have suction, so you're not even quite right about that one either. By conveying pressure, right? I mean, stuff way down here in the drain goes through, and as it moves, it pulls on the air, expands it. The air doesn't like that. It wants to contract, and that means it pulls on the water, the air, you know, and it just keeps doing that. And the more water you get into it, then the more it just pulls on the tension in the water. So as you create an absence of pressure in front of the water, the rest of the water has to come along because it's magnetically stuck to each other. The water molecules are magnetically stuck to each other.
Acceleration, it's centripetal in increasing inertia and acceleration.
All right, centripetal in creating inertia and acceleration, even though it's a lack of inertia, I'll say later. But anyway, so anyway, this is supposed to mean something to somebody, right? This is how you explain why two magnets attract or why they repel, is to use words like it's centripetals.
Whereas water coming out of your shower would be centrifugal and divergent.
So it's centripetal or centrifugal. So one is, it's spinning one way or it's spinning another way. Now, there's no evidence any of that shit's happening in my shower. I don't see it doing any of that crap.
Here in the case on the side of each and every magnet, this is not my premise. This isn't theory or speculation.
Yeah, it is. It's just complete horseshit that you make up.
This is a hardcore damn fact.
No, it isn't. None of your hardcore damn facts are hardcore damn facts. They're all bullshit. Like thinking magnets are bending light. That's not happening, Ken. That you're changing the speed of light. That's not happening either, Ken.
We have the interlacing between the centrifugal divergent and the centripetal convergent.
All right, I said it 14 times already in just 48 seconds of video. And what does it mean? What the fuck does that shit mean? This is spinning this way and the other thing's spinning this way, and somehow that makes things happen and everything's magnety. Magnety everywhere.
And the pressure mediation between the two. This is undeniable. And this also explains absolutely every oddball phenomenon.
It is completely deniable and it's refutable. So that's the catch. Yeah. All right, going to get a big dish of beef chow mein. So I guess you're just trying to be obnoxious. So I guess I'll just say, fuck you. I hope, yeah, I hope Mohammed finds you repulsive and sends his minions to smite you. If light is electric and magnetic, should a magnet bend light? Well, I've already raised that point about 7 million times, that it's kind of funny that they call it the electromagnetic spectrum when you can't move it with either electricity or magnetism. And they claim, though, you can move it with gravity. Yeah. Why? Bent space somehow works. Since it's called an electromagnetic field. Well, again, it's not really an electromagnetic field because they are claiming they're two separate fields, one going this way and one going this way. So it's two different oceans, you know, somehow.
Now that people are unable to comprehend. Why, for example, like the world's or the universe's most diamagnetic elements, say bismuth, for example, it is repelled by the edge of a magnet, but it will actually accelerate. You can actually feel it attract.
You can feel it. So a lot of his experiments have to do with some kind of feeling thing. He can taste the south and north ends of a magnet. He claims he can do that. Now, that'd be interesting if he could prove it, right? I mean, none of the physicists can do that.
Acting, or actually accelerating.
What if you can bend light, but it's too small to see? Well, clearly, if you don't do the Einstein crookeding up of the equation by doubling the mass of the sun, for example, just for light. So when light goes into the equation, Einstein's math says double the mass of the sun. So yeah, that extra gravity helps. So without that, yeah, it'd be really hard to see any bending because it's such a slight amount of bending for something moving so rapidly. But I would argue that the evidence is still so inconsistent because when you do see it somewhere, you're supposed to be able to duplicate that. That means when you have circumstances that look the same thing should be happening. And there's lots of cases in the universe where we know there's gravity and the light isn't getting bent. We know light's going through it, but it ain't happening. And so there's huge inconsistencies. The evidence doesn't match the theory, and the theory is really mushy in the sense that you're just creating a fake different universe just for photons. Just for photons, gravity is twice as strong.
Where's the center? Why, I thought diamagnetic means hates magnetism. It should be repelled.
No, it doesn't. So diamagnetic doesn't mean it hates magnetism. So that's just a silly, it just means there's some things that are easily magnetized and some things that are really hard to magnetize, but that's all. I mean, this is just silly to say it hates it.
And whether it's the edge or the center, not the case at all. So let's talk about this and go over magnetism. What is a magnet, specifically in this fourth section?
So he's going to get to it again. So basically just started over. So he said absolutely nothing, mishmash. And now he's going to start over and say some more mishmash.
You should have listened to Eric Dollard.
No, I shouldn't ever do that. It'll hurt you.
When he said that you cannot understand electrical theory without a firm grasp of counter space. It is absolutely impossible without it. These are
right. So now we have another concept. So we had all this swirly crap, and now we have counter space. So as if the idiots using things like bent space and space-time and all that mush isn't bad enough. He has to copy their bad practice by saying, let's just invent gibberish words. And let's call something counter space when we really mean something space. Yeah, right? Or ether space. Or anything you can call it, but it's not really counter space.
His words, not mine.
Yes, garbage words. Thank you. I really so appreciated.
He's far more correct than even likely he knows on that point.
Okay, yes. Ken is so arrogant and so full of shit. He said, I know Dullard better than Dullard knows Dullard, boy. I know, I'm so ahead of him that I can grade his report card. It's just so funny. Hilarious.
Point. There's a quote from Nikola Tesla. There is no.
So he moves from Dullard, which says nothing, counter space. You must understand counter space. And I'm sure Tesla said something like, spacey space. You must understand spacey space.
Energy and matter other than that which it receives from its environment, doesn't it?
All right, energy and matter, blah, 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 blah. Obviously, everybody understood the conservation concept. So again, the Tesla wasn't being exactly remarkable in recognizing that there's stuff. And what's really happening is the stuff is changing. It's like who's got gas in their car, you know. That's the only thing changing. That's even a good example is gas sort of burns, you know, and then you have to account for it going into the air, and then it has to go back into the ground, and you know, go through the cycle. But everybody kind of understands that the energy cycle, that there's a cycle of energy. I mean, they did experiments back in like the 1800s, really, you know, pretty clever, where they put a bunch of crap in a beaker and then they let it rot, and they find out everything they put in there is still in there or was released, but they can account for every little bit of movement.
And the ether, of course, the medium or substrate. And of course, it doesn't matter.
All right, the medium or substrate. So I don't know if he was really quoting Tesla there. So I think he was adding some words that Tesla might not have said, but we'll see. I'll go back a little.
Other than that, which it receives from its environment, as meant the ether, of course, the medium.
So as he meant the ether, he just said, so again, he put the word ether in Tesla's mouth, and that's quote.
Medium or substrate. And of course, it doesn't matter if we use the word 0-point energy or vacuum.
All right, 0-point energy or vacuum energy or ether or lack of inertia or counter space. Well, it does matter. You ought to have one fucking word. I can't imagine if we had 17 words for everything. It just makes conversation impossible.
Energy or the ether or dark matter. I don't care. Mother Nature does.
All right, so dark matter now is apparently ether. So I can call dark matter ether, and it's okay with him. Same difference. I can call it counter space. So dark matter is counter space. Even though dark matter sounds like complete made-up bullshit, I don't even know why he's suggesting dark matter is a real thing. You got any pictures with your Nikon 750X of some dark matter? You know, you got any $5,000 camera pictures of dark matter?
Doesn't give a damn about what stupid, petty, dumb human beings.
Well, who cares? It really isn't about what nature is doing, because nature is pretty stupid in the sense it doesn't even have a skull to put a brain in. You know, brainless nature. Why do I care that nature doesn't? I would expect nature not to. Just as I expect the space to be stupid, because space doesn't have any brain. Unlike counter space.
Call something. We're referring to one thing and one thing only. So before beginning to define the magnet, there is only one field, the ether, in its most basic manifest.
Okay, so there's only one form, the ether, in its basic manifest. And the ether is, all right, counter space, dark matter, lack of inertia. I forgot them all already.
Field is a dielectric.
So the ether is a dielectric. So we have another. We can put it in the category thing. So every time we want to say ether, we could just say the dielectric.
Other fields are merely geometric modality expressions.
All the other fields. So apparently there are other fields. So we have ether, and then we have a bunch of other fields, apparently, that are just modalities. Yeah, okay. I don't know. Modifications of the ether. So let's say the ether then is, so we could say it's sort of like the photon theory, except there isn't an elemental piece of substance. There's some sort of trampoline material, and somehow it turns into steel or rubber or banana skin, depending on something or other. Blah, 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 blah. A little harder, in my opinion, to change the jello. You know, to say there's this counter space made of jello, and that somehow you can turn it into anything you want, anytime you want. I mean, it just converts into pudding or some other silicone breast implant juice.
Field, retroductive Platonic logic necessitates this to be so.
So retroductive blah, blah, blah necessitates. So he's just trying to say, because I say so, and I say so, and I say so. Like somehow there's some logic that creates the necessity for me to believe there's a ether that shape shifts and becomes, cement or Elmer's glue, depending on the circumstance.
Since at the center of a magnet, for example, there is no magnetism. The center of a mass of gravity, there is no gravity. At the center of a dielectric field.
Yes, well, it's sort of a trick question. Okay, because it's not really true in the first place. There's no imbalance in the force. And it's always the imbalance that creates motion. So if the two forces are balanced, the pressure is balanced, then you could say there's no imbalance, but it'd be wrong to say there's no pressure. So that's where it's sort of wrong. If you understand gravity as being a pressurizing modality. Let's see, and how else to explain that? There's other examples.
Field, however, there's the highest concentration of same. So let's get to it. And I like.
No, the highest concentration of same is on the surface. That's the highest concentration of the imbalance.
If you to take a look at this lecture this image, excuse me, long enough.
But the irony is that the most pressure is on the inside, right? So you want the highest pressure being caused by gravity, you go right to the center, because that's going to be the highest pressure, because all the little material bits have all been moving in that direction, and all that movement is like getting hit by a bunch of bullets. It'll crush you.
Hard, and let's explain it here in just a second. So let's get to it. First, let's define a magnet and state the obvious, that before becoming a magnet and after becoming a magnet, there is...
Why 36 thumbs down? Well, clearly there's just a lot of people that have 3.6-inch penises. There's just, yes, very, very, very little people. Lots of little people in the world.
Zero quantitative change, be it ferrite, samarium, cobalt, neodymium, iron, boron, or otherwise. Magnetodielectric elasticity, so to say, or the atomic and molecular nature of the object, defines its ability to become a magnet. And
yes, we all could agree on that chemistry seems quite obviously involved. Only certain elements can become only certain atoms in certain conditions can be magnetized, become magnetic.
As has been demonstrated, we can polarize strawberries and living frogs in a strong enough magnetic field, a really high magnetic field, but only temporarily so. Most neodymium magnets, for example, are magnetized with 2400 volts and 12 amps DC.
You don't even want to get into. There are lots of ways of creating a magnet. You can use voltage, which is sort of, you could understand how that's related to heat, but you can also just use heat. You heat the material and then expose it to a field, and as it cools, it will cool with all the atoms lining up properly in the proper domain positions. Head north, south, north, south, north, south, north, south, north, south. That's what you're after.
Thousands of years now, we've been certain that magnetism was the reason why these magnets accelerate towards one another. But this is not true at all, and an absolute logical impossibility.
Okay, so the magnets don't accelerate towards each other. So his argument is something like the counter space, the ether, contracts. So they're not moving towards each other, they're moving into the lack of counter space. The absence of ether Doesn't really say anything, but okay.
In the manifestation of the conjugate magnetodielectric field geometry, magnets accelerate towards a mutual null point.
All right, so this is supposed to be this clear, easy, simple explanation of why magnets work. I could play that 30 seconds to any test group, and then we'll test them on it and let them explain what they just heard. And what do you think you're going to get? Do you think you're going to get anybody who's going to have the same response and be able to explain what Ken just said the same way? No, no one will.
Nexus in counter space, not towards each other. This is clearly also seen underneath the ferrocell.
So there's somewhere under the ferrocell you can see that the magnets are moving towards the nexus of counter space. Whatever. Prove it. Demonstrate it. Show it. I haven't seen it yet. I don't know what this is. Free Kavanaugh from Facebook jail. I don't even know what that means, but too fucking stupid. Little warped. He's a little warped. I don't even know how you have all these accounts. You know, I don't know how they can get all these accounts. Frankly, it just doesn't make sense.
On the right, you'll have a look at this diagram in other places. This is from Charles Proteus Steinmetz's field diagram of the AC circuit, the electrical circuit. And here we're looking at the circular lines. This is one where he gets it right. I hope you notice this pattern.
This is one, he gets it right, which is funny. So again, he's talking down to his heroes. And so now he's switching to electromagnetism, which, you know, is kind of a different subject. I mean, it's the same phenomenon, but one can intuit that you should explain why magnets move into each other and repel each other before you start getting into electrical circuits.
And we'll talk about it here shortly as well. This would be also the same diagram, the field diagram between the dielectric manifest in blue and the magnetic in these circular orange circles. This is the same field you see in AC power lines going down your street. Now, if I were to actually take this...
So again, we don't see any of that. So we see the AC power lines. We don't see them moving towards each other, doing any of this crap. So it's all sort of blah, 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 blah. Not very good evidence of anything. It's obviously not very strong magnetism.
Same field diagram and put a black box around it. Okay, we have the exact same conjugate magnetodielectric hyperboloid and...
All right, so the same conjugate something hyperboloid. Again, this is an explanation. People said, oh yeah, Ken Wheeler, he knows this shit. He's talking real, this is how magnets work. Nature doesn't use any of those words. Use a Ken Wheelerism. Why does nature give a shit with your bullshit jargon? Why don't you draw a picture of it, Ken? Show the magnets. Show the force, the energy. Where's the energy? Move the atoms.
Torus. By the way, the inverse of a torus is a hyperboloid. The inverse geometry of a hyperboloid,
says Ken again. Really, no. I mean, the hyperboloid is a donut of circles. Torus is a tornado. Not exactly the opposite of each other.
Meaning an hourglass shape. It's a torus. These two superimposed upon each other, of course, form a sphere. The torus, the donut shape, and the hyperboloid, the hourglass shape. These are negative images of each other.
No, sorry. Fine, but I don't think so. Yes, that's okay. Fine, but I don't think so. They don't want anything to create a sphere.
It is also the case that the maximum, this has been proven by supercomputer model.
Oh, here we go. Okay, so he said something's been proven by a supercomputer. It'll be interesting.
Where you turn a sphere inside out to its maximum.
So you turn a sphere inside out to its maximum with a supercomputer.
The absolute inverse of a sphere is a hyperboloid.
Is a hyperboloid. Well, whatever. I don't think so. Yeah, that's what I'll say. I don't think so. I don't think you can turn a sphere inside out. I think it's a silly concept.
Everything that,
It's like turning a square inside out. Why don't you turn a square inside out? I don't think so.
it defines force in motion, space, force vectors is magnetism. You remember when your idiot teacher said, every atom in the universe is 99.999999999% empty space. Like if we were to take all the empty space in every atom away, like the entire...
So he says that's idiotic when, yeah, it's sort of the evidence indicates, though, that that's sort of how it works, because you can shoot an awful lot of stuff into atoms and it doesn't hit nothing. And it's only because there's a lot of atoms that you eventually hit something.
Earth would fit into something about the size of a large marble. Well, it's not empty space at all. It's just the magnetodielectricity, or the air in the balloon, if you will, of every atom measured in picometers, the interatomic molecular radii of any and every atom in the universe. That is magnetodielectricity.
So did that make any sense? I don't even know how to paraphrase that. I don't even know how. It's electricity because it's an atom and it's surfacey stuff.
That is the air, if you will, or the so-called space that makes up the molecular, the atomic diameter in picometers, measured in picometers of each and every atom. So here we have the exact same diagram between these two. The field geometry is 100% identical. You should actually...
It's not true, but whatever. Obviously, he's not working very hard on providing visible graphics, but he has wires going in and out, you know, and then he has a picture of, I guess, a magnet from above.
Study on this. You would actually study on this, you'd make an interesting visual connection to what the hell is going on. By the way, if aliens, and I'm only saying this, not talking about aliens at all, if aliens were to land...
So now we have the testimony from the aliens. Yeah, they say so too. They're quite sure. They really love hyperboloids, the aliens. Oh, toroids. Love them.
To prove that us stupid human beings are even slightly evolved, we wouldn't have to show them anything, or like, all we'd have to do is show them this diagram. I said, oh, these human beings, they understand that.
So it's just kind of silly, because the diagram is based on, it's based on measuring field strength, and it's just a proportional relationship. It doesn't have anything to do with any explicit lines. It just has to do with the fact that there's twice as, because of the inverse square law, there's 4 times less energy here than there is here to a charge or to anything. So it's just a representation of the proportions of the energy. There is no explicit line. There's nothing is going out and flying down and going back in again. No evidence of any motion around a magnet. 0 evidence.
Nature of the universe. This is the conjugate magnetodielectric geometry of the entire universe. Here we have the torus and the inverse image. We actually have the hyperboloid. Anyway, I could actually discuss that for hours. That is a long discussion to talk about that one.
Yes, it has nothing to do with magnetism, apparently. But anyway, fine, whatever. It doesn't explain why 2 magnets attract and then I flip it over and they repel. It doesn't explain any of that.
Here we have actually a frog levitating in an ultra high, I think it's like a 6 Tesla Gauss field, a living frog. So people don't...
So some idiot brought up this stupid frog crap. So yeah, so apparently they torture frogs for no real good reason. And again, I will just argue that just intuitively, you can argue that there's enough iron in the frog, iron oxides and whatnot, for the little bits of that alone to be enough. It's like if you ate a bunch of magnets, then they could levitate you or whatever. So it just has to do with just having some magnets in you, and those will get levitated and you'll be dragged with them. So the copper and the iron and any other paramagnetic materials inside the frog are obliging the frog to obey what those minerals say gravity is, which is now nothing.
Realize that all is the field itself. Just as magnets do not accelerate towards one another, neither is it.
So again, they don't accelerate towards one another. So he reiterated it, except they obviously do. I mean, obviously are horny for it. I can put a piece of glass between them. Yeah, they still want to get to each other. So whatever the ether stuff is, I can put all kinds of plywood, a piece of plywood between the two magnets, and they're still going to attract. And it doesn't matter what material I put in there, they're still going to be attracted. But let's just pretend somehow they're not. Somehow the magnet isn't moving because it's being compelled, not because it's jumping into counter space. Not because the plywood has a bunch of counter space in it.
Anything present in the void of a ring magnet, yet when viewing same underneath the supercell, it has the exact same magnetodielectric.
So again, the supercell is being sold as a way of viewing the actual fields around a magnet when it's clearly an optical device. The thicker the glass, the different images you see. Clearly it's not giving you an accurate representation. The iron filings are doing that. I mean, they're giving you an accurate representation of field strength. Again, they're not where the filings would go if liberated. if free to do what they are being obliged to do, they would stick to the magnet because they're magnetized.
Image is any pole of any magnet. Take a look and discuss this one here shortly.
Yeah, it's another one we can't see, so that's really good that he has his visual aids. I wonder if he has a link to them. One image of Brian Kerr. See his channel here. So yeah, he really should. If you like these videos, that's all crap. So he could give us a link to whatever page this is. His book, if it's his book. But no.
It might be simple to think of a magnet which has been charged with 2400 volts and 12 amps DC as a permanent field photograph of the charge which has passed through it. The magnetodielectric geometry.
Okay, clearly that's not what's happened. It's not a fingerprint of anything. It's a deliberate effort to figure out a mechanism to take atoms that are in all kinds of directions and force them all to be in the same common alignment. So that's the objective, is take the geometry that might be mixed and make it all the same geometry to concentrate the plus-minus effect, to avoid having a magnet, where this is the red end, this is the north, the black end. And I should put black tape on something, and then I can do this better. Well, make a better example. I'll just use this pill bottle. So let's say this is the north end, right? And I don't have two pill bottles. And these are the common ends. They could be attached to each other this way, right? And be non-repulsive. They could attach this way, right? So if you have a magnet going this way and not this way, then you can see how that's not going to concentrate your magnetic field. So what you really want them all to do is end over end over end. And then you want the ones that are next to them to be end over end over end, just staggered, and then back to staggered on this side and staggered on the, and that way you maximize how much of this effect I was talking about, where the black stuff comes in and goes out red. You're maximizing it. So you're doing it for each one is shooting the red stuff in the same direction, which makes it a more and more powerful magnet. But that's what you're doing. You're not fingerprinting something.
That defines a magnet as point source, not merely domain alignment.
All right, so point source, which really doesn't mean anything. Everything is point source in the sense that photons come off of points. Little atoms are where the photons are coming off of. Okay, the electrons associated with atoms. It's coming off a point. Clearly, the magnetism is likewise going in as little bits of force and coming out as little bits of force, and at every conceivable angle, just like a light bulb. That's the inverse square law. And so anything that produces the inverse square law is essentially point source.
Descriptions are not explanations. To say that
and whatever this crap is, it's not an explanation either.
Magnet is an object which has aligned domains is a superficial farce, which
okay, aligned domains, he says, is a superficial farce. Now, the idea of the domains is that you have an ability in some materials like iron and other substances to get these alignments to happen, and they happen in groups. But then other groups next to them can be aligned completely different. So you'll get sections of them to line up, but it's hard to get the whole, all of them to, because of the energy in the sense of there's enough heat or enough motion in the atoms, enough jiggling, that they can switch too easily. So the trick is, so that's why you can take a piece of iron and you can magnetize it, but all you got to do is give it a little bit of a tap, and all the domains break apart and start going in all kinds of directions. But it's just saying you can clump the magnetism in some materials that, and it's been pretty well established that this is true. Lots of experiments demonstrating this domain nature, and they even make magnets this way. That's how they make magnets or keys. Is they magnetize them in different directions. They can draw pictures. They can put your face on a magnet, where the magnetism would be strong, creating lines that could duplicate your face. And those are because you can control it in sections, in domains. So again, he's saying it like it's nonsense when it's well-established theory.
Neither explains what a magnet is nor how a magnet works. Collectively,
I don't think anybody was saying that that's the beginning and end of the story of magnetism as domains, but it's certainly a clear connection to the fact that this is an atomic phenomenon, that the atoms are what's lining up. And when a group of atoms line up, it's called a domain. And when the domains line up, it's called a strong magnet.
Humans think, due to 5,000 years of experiential observation, that a magnet is an object which emits a magnetic field.
Well, that's one of the things that admits something clearly. This one magnet senses what the other magnet is emitting. So just like the moon senses the Earth's presence, the magnets sense the presence of the other magnet because of something emanating from the magnets. Now, I would argue, obviously, it's just gravity, but it's been filtered, so now they can see it. Clearly, that's happening.
And that magnetism
and clearly they know how fast that communication is happening, and it's happening at the same speed that light travels, the same speed that gravity travels. It's moving the same speed as the little bits that make photons and that make gravity and now make magnetism. It's all the same stuff, moving the same speed. And you can use it to communicate, just like we can communicate with these little bits of stuff. Magnets are communicating directly with each other. Force. is the medium of the communication between the material substances.
Causes other ferromagnetic objects like nails and iron filings to accelerate towards it.
Well, it first has to magnetize them. So first, it changes the orientation of their atoms to line them up, and now they become a filter too, and now they want to be lined up opposite to the main magnet. So the main magnet imposes magnetism. All right, the two magnets can't be the same, okay, because that would make them repulsive. So they're created inversely and then attract.
All of this nonsense is due to the inherent defect.
So he calls it all nonsense when it's really well established by lots and lots of experiments. So he never debunks an actual experiment performed by physicists. I haven't seen him do that yet. I haven't seen him show any physics experiment and actually explain how it's wrong. Now, I think that's doable in the sense that I think the two slit experiments, some of them are crap, lots of things are crap. He doesn't do any of that. He just makes this claim that it's wrong, but yet he doesn't have any evidence of it being wrong. He doesn't show us how it's wrong.
Of human sensory input and also human ignorance, of course. This is also due to the
I think it's ignorance when you make claims you don't demonstrate or prove with evidence. Evidence is something smart people understand they have to have. If they make a claim, smart people know, oh, I have to be able to demonstrate that claim. I have to be able to make a logical argument, or I have to show, a physical reality. I have to demonstrate it to be true, or I have to make a really good argument for why it's true. I can't just keep claiming it.
Logical and faulty thinking methodology of intellectually unevolved humans.
Right, and I think it's really uninvolved when you don't understand your obligation to prove what you say, to demonstrate it, to explain it in rational verbiage.
Aligned magnetic domains are far less a full description and no explanation at all. Rather,
the huge explanation. I'm just saying, taking a bunch of little atoms that are little magnets and piling them up top of each other to make a bigger magnet is something we all can do. We can do that. We can take little magnets and we can stack them on top of each other and they become a stronger and stronger magnet. I have a little magnet I can't get off the surface. So we can all experience that. We can all experience just piling little magnets up, make a stronger magnet. It's completely doable. And the theory he's saying is nonsense. It's a theory that merely says the atoms are themselves little magnets, and if you line them up, they'll do exactly the same thing. They'll create a bigger magnet.
A magnet is defined by having point source field incommensurability.
So that means something to anybody, right? So I could throw that on the, let's do a sample, a sampling of American people or foreign people or anybody, and they're going to know what the fuck that crap was he just farted.
I'll soon explain that in the next section.
Oh, just can't wait.
Section 5. By the way, I just use this as a perfect analogy.
I don't think it's going to be perfect at all. Not anywhere close to perfect.
We have an hourglass, a sand hourglass. We obviously can't take this analogy too far. We have sand that goes from one side to the other. We turn it over. But if I actually overthrow a white outline over this, we'd actually have the same sort of premise on several levels of the analogy of a magnet.
All right, so somehow the magnet is, I would agree, there's obviously, to some extent, at least this is acknowledging the polar argument he was denying before, that clearly the two pieces are different, and the one's stuff is, again, I just don't want to get into this argument. Yes, stuff moves this way, and there isn't stuff moving this way. But there's no other way to move. The movement part is just a waste of time. The two are obvious. As pointed out, the two charges are doing the same thing. And so it's like an hourglass with sand going both directions. And I'm just going to turn it back into a charge argument. The black sand goes this way and the red sand goes down. The two go in opposite directions, creating a red bottom and a black top, you could say. Which is sort of what he has illustrated slightly. I don't know exactly why this was different colors, but just to my purpose, that's exactly the point I'm making, is that one side becomes all electron force sensitive, and one becomes proton force sensitive, or producing. Just raining here. It's so bad. Oh. Anyway, so this is probably enough. I'll see if the commenters have anything to say, and if not, we'll just call it enough of a video. So I do want to work on, I really do want to do a good analysis of the ferrocell eventually, and I'm hoping this stuff I'm doing on optics is going to give me the weapons to do a proper analysis of why this mechanism is not a test instrument. It's not a scientific tool. It's a frickin' toy. It's not revealing magnetic fields. It's revealing how complex light diffraction is. Can be. Especially in thin films. This is so, it's like the same effect that happens in water droplets, soap bubbles and oil slicks, and how the little tiny changes in the thickness of the material create changes in what shows up as light and dark, where the photons go. So, yeah, and such. If there's anything else. So yeah, just not much happening in the world of physics. Hey, that image is frozen. Oh, that's the video. Okay. So this should be the live one there. Yeah. Okay, it's all shrunken. This is the one where I gotta turn it off. But yeah, okay. Yeah. All right. So anyway, yeah. So I don't think there's much else. So again, if somebody really wants to have a conversation about physics and defend the conventional model against my model, I'd like to engage in that conversation and such. So I guess that's it for now. So till the next time and such. What else? Not now, yeah. Yeah. It's disappointing. Deaf ears and such. So, look at that. 8 viewers. It's pretty bad. Thursday nights. Yeah, Thursday nights are just not too good. Friday morning, however you want to look at it. But this does seem like just wasted opportunity. Unfortunate. So, till next time.